Good morning, first period.
Good morning, man.
It's a short week. Let's get to work day as quickly as possible. I have today. Today's just definitions. Okay, so just copy with me. Okay, at least 5. I hope to get through at least 3 today. All right, as you can tell, I have different colored pens. I'm going to have a ruler today because there's going to be a lot of triangles to draw. You may want some sort of straight edge just to keep it all neat and pretty. And pretty. All right, here we go. Here's the first definition.
Hey, miss, guess what happens in 4 days?
In a bit. Hi. Shh, keep up with me, please. I know the definitions are the most exciting things in the world, but bear with me. We have to get through these words so that you are armed and are able to do all the rest of the stuff that you need to do. Okay, I'm going to leave a bit of space right here. Let's go ahead and draw the triangle. Let's draw the triangle. All right, so the first word is perpendicular bisector. It's a word you guys are already familiar with. But in a triangle, the perpendicular bisector is that line that cuts this one into 2 equal segments, because it's a bisector.
Oh.
And it forms a right angle.
Right in the center.
Yeah. Doesn't necessarily connect to the angle over here.
It doesn't?
Does not necessarily do that. We don't really care. All we care is that it forms a right angle to one of the legs and cuts it into 2 equal parts. So here we go. Here is the word definition to go with the picture. It's a segment that is perpendicular. Remind yourself what perpendicular means. Intersects at a 90-degree angle. Awesome. Which means if you're looking at the slopes of the lines, those slopes had better multiply to. Y'all remember? When you multiply the slopes of perpendicular lines together, you're going to get a number. What number are you going to get? Uh-oh. Time to comment to yourself. You're off to the left. You're going to get a -1.
What does that say after side?
Into.
And here? Into.
No, side, the first side.
Side and cuts. I didn't give enough space over there. All right, it says a perpendicular bisector. It's a segment that is perpendicular to the side, any of the sides, and cuts the side into 2 equal parts. How many perpendicular bisectors
Hello.
does this triangle have?
Oh, no. Oh, well, 3.
It'd have 3, 1 for each side.
Yes, ma'am.
Yes, sir. All right, so we're going to underline perpendicular real quick. And we're gonna put our little recall symbol, which is like our recycle symbol. Over here, we need to recall a couple things about perpendicular. As was said over here, perpendicular lines hit at a 90-degree angle. So we're reminding ourselves, intersect at a 90-degree angle. Another thing that we need to remember is that the slopes multiply and give a -1. Okay? So some important things to remember about, ladies and gentlemen, thank you. A couple important things to remember about perpendicular lines. Like I said, today's just going to be a bunch of definitions. All right. The next one is the mid segment. Oh, I misspelled that, did I? No, I did okay. No, I did okay. I did okay. All right. Gonna draw another triangle. Here's what mid-segment looks like. Gentlemen, conversations later, please. Gentlemen, thank you. Thank you. So a mid-segment is going to connect the midpoints of two sides together. This blue line is the mid-segment because it's the midpoint of this side and the midpoint of this side. So in words, it's the segment whose endpoints are the midpoints of two sides of a triangle. There's a special thing to know about this mid-segment. This mid-segment ends up parallel to the other side that it's not intersecting. So the mid-segment is parallel to the third side of the triangle. Can you see some problems that might be asked with things like this? Hopefully. We can get through all these definitions today. Hopefully we can start on the examples. Definitely going to have some examples of it tomorrow, for sure.
Well, if you do all three, you're going to end up with 4 tiny triangles.
If you do all three, you might end up with 4 tiny triangles, yeah. All right. Nice.
Is that correct?
Yeah. Yeah, definitely. Most deaf. All right, gotta scooch it down here. Here's the next one. We are just flying through these. The next one is median. Again, gonna draw another triangle. In this one, it starts, bless you, it starts at the one of the vertexes. It doesn't matter which one, it just starts at a vertex, and it's going to go to the opposite side, and it doesn't matter what angle it hits at, but what's important is that it hits at the midpoint. I don't care what the angle is. So I'm going to make myself a little note right here that says the angle of intersection is unimportant. Which is different from that perpendicular bisector up on top, which is it had to hit it at 90. This one, we don't really care. So in words, a median is, now please be careful with median, right? Because it kind of sounds like from algebra, right? Mean, median, mode. Remember all those? This is a geometric median, okay? It's a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. We're doing real good. I'm going to pre-divide my remaining space because I want to get all 5 of my vocabulary words on one page. There we go. So I went ahead and pre-divided this. This will be it. These are all the vocabulary words I have for the day.
Wow.
Yeah.
Awesome.
We're doing really good. The next vocabulary word is the altitude. Okay. Again, going to start off with, oh, come on, ruler. Again, going to start off with a picture. And again, doesn't matter what the triangle looks like. The altitude is a segment where the endpoint is the vertex, and the other endpoint doesn't matter where it runs into the other side, as long as it does so at a 90-degree angle. So in this case, that angle of intersection is important. That's super important. So in words, the altitude is the segment whose endpoints are a vertex and, it doesn't look like an X, a point, oops, a point on, oh, hang on, on the line containing the opposite side so that the segment is perpendicular to the line. That seems kind of oddly stated. Like, instead of just saying the opposite sides, it says the line containing the opposite side. And it's because it's entirely possible for an altitude of a triangle to end up outside the triangle. Okay? So let me draw a little quick example of what it would look like over here for us to have an altitude that's outside a triangle. I'm going to draw it really small. Hi. So if I were looking at this vertex and I wanted to create an altitude of that vertex, notice if I go down in here, it's totally not going to hit at a 90-degree angle.
Right now.
Yes, thank you. I'm not going to be able to do it. It's going to be at some weird angle. So if I'm going to drop it straight down the way it wants, I need to take this side and kind of extend it out a bit more. And then I can draw a line from this vertex to that line that hits this 90-degree angle. Do you see it? Okay.
Why only one angle? Unless you have an equilateral. Compatibility? Or close to an equilateral?
Well, this one certainly is an equilateral, and I was able to have the altitude be inside the triangle.
No, yeah, it's only going to have one altitude, but like, if it's anything.
Well, this one will have a different altitude, and they'll all be inside. So all triangles are still going to have 3 altitudes depending on which vertex you start from. But there's some cases, like in this one, where the altitude ends up outside of the triangle. Okay, and so that's what that's hitting at the point on the line
Really sharp
containing.
triangles.
Yeah, usually the obtuse-ish ones are the ones that end up doing this. Okay? So that's what this line is talking about, this line containing. So take a moment and underline this line containing the opposite side. Put your little question mark about it because that's a little confusing. And then over here on the left, that's what it would look like for it to be outside of the triangle. Hopefully that'll help you remember it for the next time you have to look at it. And here is the last vocabulary word for today.
That looks awfully familiar.
It does, doesn't it? And I think one of the questions on your workbook pages had this word angle bisector, and some of you were looking at me going, what is this word? I'm like, hang on, I haven't gotten there yet. Here it is.
I got this.
You got this. All right, so we're going to draw our triangle. Oh, this is going to be a kind of a wonky one. There we go. Kind of a crazy looking triangle. All right, the angle bisector is going to start from a vertex. It doesn't matter where it goes to, but it's got to make these angles congruent. My picture totally didn't do it, okay, so obviously, John, not to scale. But it was supposed to. So it's a segment that bisects. It bisects. Let's start here with the definition. It's a segment that bisects an angle of a triangle. Gentlemen, later. With one endpoint at the vertex of the bisected angle. What do you think bisected means?
Cut in half.
Yeah, the angle that got cut in half. So if this was a weird word for you, underline it or highlight it now. Put that question mark and put over here to the left your answer. And the other endpoint on the side opposite the angle. There's one kind of little important note here. I'm going to put the star in green just to make it a little different. The angle bisector is equidistant. Didn't we use that word before? What did that word equidistant mean?
It's equal.
Equal at the distance. Yeah, equal distance. So if this is a word you don't remember, here's your little question mark, equidistant. Yes, sir.
Miss, I have a question.
Yes, sir.
And you're probably going to answer it with that word right there.
Okay.
But if the angles are congruent, wouldn't that mean the secondary endpoint? Wouldn't that mean that the distance on each side is equal? Is that what equal distance means?
Yes.
See, that's what
Lovely. The angle bisector is equidistant to the other sides. So I think that that answers your question.
Yeah.
So the distance from here to here is congruent to the distance from here to here. It totally doesn't look like it in my drawing, I'm sorry. This triangle's kind of, yeah, it's leaning away from us. It's like it's taking a selfie, you know. Gotta lean one shoulder back to make it look cool.
What's a selfie?
It's a selfie. We're in the 21st century.
All right. Triangle selfies.
Miss,
Yes.
doesn't make sense of the
Which one?
where it says endpoint on the side opposite.
All right. So there was a, gentlemen, quick question came in about this, this part of the definition right here that said that the other endpoint is on the side opposite the angle. So you're going to have one endpoint here at a vertex, and this is the angle right here that is going to get bisected. The other endpoint isn't somewhere random out here. That other endpoint is on the side inside that angle. So that's what that's meaning. Okay? It's, yes, you could totally extend this up this way, and then you'd have the endpoint out here, but that doesn't help us. It has to be inside the triangle. Great question. Thank you.